Hi, it's Jan Beta, and today I'm going to put the finishing touches on the Amiga 1200 that I saved from the flood in the last video. As you can see in the background, the Amiga 1200 still works fine after cleaning it in the last video. And today I am going to do some retrobrighting on the keys because those were a bit yellowed. The case came out really nicely and doesn't have any yellowing on it basically, so that's going to stay as is after cleaning. And what I also want to do is to replace all the electrolytic capacitors on the board, and then I'm going to put a compact flash hard disk in there as a final step. Yeah, apologies for the delay after part 1. I hope to finish this series in this video. DHL managed to delay delivery of this capacitor pack that I ordered for quite some days, so I couldn't really do any further work on this Amiga. The plan for today is to do some retrobrighting on the keys, and while that process is going, I'm going to recap the whole board, replace all the electrolytic capacitors. I have the SMD parts and the through-hole parts in this pack. And yeah, that's the plan. So let's start with getting the retrobrighting going, I guess. So I put all the keys in this container, and I don't know if you can see it, but they are, some of them are really yellow. This one in particular. They are cleaned, and I'm going to use some liquid hydrogen peroxide. This is a 12% solution, or 11.9. And I'm just going to cover them in this container. And now we need something to accelerate the chemical reaction. That is basically a bleaching reaction. Jeff Bird of the Hey Bird YouTube channel made a very conclusive video about retrobrighting and came to the conclusion that it's basically a bleaching process, just like sun brighting or any of the other bleaching processes. So hydrogen peroxide is a chemical way of achieving that because it's autumn here in Germany and we don't have a lot of sun anymore. I'm just going to use this and put it in a little insulated box and have my UV grow light sitting on top there, which also acts as a heat source and is going to heat this liquid up. You don't want to heat it up above 60 degrees Celsius. That's kind of the point where the plastic starts to deform and melt, and you don't want to go above that. Yeah, here's my retrobrighting box. It has some bubble wrap on the outside and is insulated. I'm just going to put this in here, put my grow light on top, which is, it claims it's a 300 watt grow light, which also emits a lot of heat and ultraviolet light. And then I'm just going to turn this on and come back every half hour and kind of mix the keys around. Usually this process gives me some very good results, and I don't usually get any streaking or any discoloration on the keys, just some straight bleaching. So hopefully it's going to work this time. And while I do this, I'm going to go back to the lab and do some recapping, I guess. Let me take a couple of seconds to thank the sponsor for this video, PCBWay. They are my favorite manufacturer of prototype PCBs, and they have their PCB design contest going on currently, where you can send in your PCB designs in various categories and win some amazing prizes. You can check out the website in the video description below. And also, if you want to have your circuit boards produced by them, you can check out their website, and they have excellent service and deliver exquisite quality. So let's get back to the Amiga. So I turned this off, obviously. I'm going to remove everything from it, including the disk drive. And yeah, several years ago when I just started with YouTube, I made a video where I used the technique of twisting the capacitors off the board with a pair of pliers. I don't do that anymore. I'm now going to use hot air to remove them because I figured that's more reliable and you don't risk damaging the board. Still, the twisting method works well for some people. I wouldn't recommend it anymore. And in my initial Amiga 1200 recapping video, I also used ceramic multi-layer ceramic capacitors to replace these electrolytic caps. I wouldn't recommend doing that anymore either, because some of the timings can be a tiny bit off. So some accelerator cards and things like that might not work quite as well as they would with electrolytic capacitors. So basically I'm going to replace same for same, and I'm using electrolytic SMD capacitors to replace these. These are from the early 90s, and that was a time when SMD electrolytic capacitors were very much prone to failure and leakage. They just aren't really good at that point in time. So most of the machines from that era, like early to mid 1990s, have leaky surface mount electrolytic capacitors. And in fact, I haven't seen an Amiga yet from that era, like an Amiga 600, Amiga 1200, Amiga 4000, that didn't have leaky capacitors, or at least ones that were kind of not in spec anymore. So it is always a good idea to do this process, or to have it done by somebody who knows how to do it with your Amiga hardware. That also includes the Amiga CD32 consoles, of course, because those were produced in the same era, basically, like starting in 1993, I believe. I'm going to cover up all the plastic parts, like these connectors and things like that, with some Kapton tape, which is a heat-resistant tape that usually works pretty well for protecting the parts. And I might desolder the keyboard connector altogether. I've done that with my Amiga 600, and that worked really well. If you're using hot air, there is some danger of melting some plastic, obviously, because you're applying a lot of heat. And it's not very targeted with hot air. Yeah, that's the plan. I think desoldering the keyboard connector makes a lot of sense, and I have my desoldering station handy here, so that's not going to be a huge thing. And I have also set up my little soldering fumes filter here, which doesn't do much. I have the window open and I have another fan blowing air out of the window, so that's always a good idea to have a well-ventilated room if you're doing something like this. So I'm adding some flux here to the keyboard connector, because that usually helps a lot with desoldering these things. Yeah, I think I'm just wiggling it a tiny little bit, but I think we got it. There we go. That did come out rather easily. And I think this process, I find it easier than to clean up or to cover this up so it doesn't melt. I'm just putting this aside while I use hot air on the board. So I'm just going to cover up the remaining parts around the electrolytic capacitors with some Kapton tape, as I pointed out earlier, and I'm going to be right back. Okay, after covering this up with some Kapton tape, most of the parts that are in danger should be covered up now. I am going to first remove the electrolytic capacitors. You could, of course, do this before covering up the rest of the board with Kapton tape, but yeah, I kind of forgot. There are some areas where they are very close to the SMD caps, so makes sense to remove these first. So more through-hole desoldering at first. And these through-hole capacitors can be pretty stubborn, so yeah, bear with me. These can be pretty tough to desolder because it's a multi-layer board. And yeah, there's some ground plane that can wick away quite some heat. I'm cleaning up with some solder wick. Okay, I got the through-hole electrolytics off, and I'm going to continue my quest with some hot air, I think, and remove the surface mount electrolytic capacitors. Now for the real hot air portion, I'm going to use some tweezers, and I'm going to heat each side of each capacitor leg until the solder melts, and I can just effortlessly, hopefully, get them off. I'm going to use some flux. Yeah, and that's just going to be some tedium, but hopefully we're going to get there. And this takes a while for each cap, but you can feel them melting, basically. And be aware that these can really explode, so you want to wear some eye protection. And you can see the solder melt, usually. I don't know if you can see it on camera. And these are really easy to take off after the solder melts. You shouldn't have to use any force for this. So these ones, you have the least room to work. The ones next to the RCHX here. Sometimes some parts of the connectors here melt a bit, but yeah, it's going to be okay. It doesn't smell fishy, so the capacitors on this one, usually if you have leakage, you smell the fishy smell after a while of recapping. So the capacitors in this one might actually have been alright. Still a good idea to replace them after all these years. By the way, I had my cheapo hot air station set up to 370 degrees Celsius and to full airflow. That works for me. Maybe your mileage may vary there a bit. But this setting has proven quite useful for me. So that's all the old capacitors removed. Just going to throw these away. And I'm going to clean up the pads. So for my next trick, I'm using some solder wick and my regular soldering iron, and I'm going to clean off the remaining old solder from the pads. There's also an unpopulated pad. If you have lifted pads, there usually are some ways to add some bodges to make the capacitors still contact the correct contacts. There's vias around these pads where you can connect to. Usually that's not a huge problem. But in this case, everything went well. We don't really have to worry much about that. And it's still pretty easy to lift these pads, especially if you have corrosion, so you want to be really careful. Okay, let's use some isopropanol on these and clean these off. I'm not a huge fan of using Q-tips for this purpose, because usually, oh, I forgot one. Because usually you have there's some lint-free stuff like lint-free Q-tips or cotton swabs that you can use. With the regular cotton swabs, you risk ripping the pads off, actually, because some of the lints can go under the pads, actually, and if you wipe too much, you can rip them off. So I wouldn't recommend using regular cotton swabs for this job here. Okay, I shall open the capacitor pack. You can get these from various sellers, and you can of course also get a list of capacitors. I'm going to link that in the description. Just order your own from your preferred electronics parts dealers. There are lists on icot.se that I like very much because they have the order numbers for the capacitors you need on them as well. This particular capacitor pack I ordered from Vesalia, who are a staple of Amiga stuff in Germany for, like, I don't know, since the 90s. So I always find it appropriate to support them a bit. These are Nichicon. I'm not quite sure which brand these are, probably Panasonic or Nichicon, I'm not sure. But they only deliver name brand stuff, and these are 105 degrees Celsius rated through-hole capacitors, so that's a good idea to put those in there as well, because they usually last a bit longer. So I'm now going to refer to the photographs I took previously when the old capacitors were still on there, and just place the capacitors where they belong. So what I usually do is to put some solder on one of the pads and let it flow on the pad. And then I grab my capacitor, in this case this is a 100 microfarad one, place the capacitor on there with my tweezers, and then I just go in and heat the solder, slide it on there. There we go, that's a nice solder joint. And this is a bit of tedium, especially if you are as shaky as I am today, for whatever reason. But it usually works pretty well. Okay, so first one is in place. And of course, I forgot to use flux. You always want to use flux with these surface mount parts. So I'm going to reflow these for a bit. Yeah, and instantly my solder joints look much better. You can't have too much flux. So, I have all the surface mount electrolytic capacitors back in. Now for the through-hole ones. First of all, I think I want to resolder the keyboard connector though. And you have little positive or plus markings on the board for each positive for these through-hole caps. And there we go! Now it should only be a matter of cleaning this up with some IPA. and then testing it. By the way, these should not come off at this point, unless I did something horribly wrong while soldering them in. But usually, don't think I made any huge mistakes here. We don't have any casualties, no ripped pads. We have a bit of melting plastic here on some of the corners, but that's not much of an issue. Okay, so now here comes the important part. Testing if this actually still works. Fingers crossed. And yes, it takes a long time, as I said in the previous video, to start up. But this seems to still work. I'm just going to leave this board powered on for a while to see if any of the caps explodes or something like that, but I have high hopes. Okay, so that's one successfully recapped Amiga 1200, I'd say. What a relief! Now I think it's time to take a look at our retrobrighting project that's going on in the background, I guess. I checked this every half hour or so and just did this to give each key the same exposure roughly to the UV light and things like that. I think they should be pretty much done. Yeah, they're way better than before, at least I can say that. It's nice and warm. And yeah, could maybe give them another round. So I'm just going to leave them in there for a tiny bit longer. And put it back on here. Maybe another hour or so. And you can actually reuse the hydrogen peroxide several times. Yeah, these look way better than before. You don't want to overdo it. Let's try to save some of the hydrogen peroxide. And then we just rinse these and let them dry. So after retrobrighting the keys, I think it's about time we put the keyboard back together. And yeah, I'm going to have to put all the little key stamps back in there, the plungers. And then I'm going to screw down the backing plate on this thing. This all cleaned up rather nicely, so I'm not too worried about any more germs on there or anything like that. Yeah. That's what I'm going to do, and basically it's just the same steps as for the disassembly in reverse order. So the keyboard turned out super nicely, I must say. There's still, I don't know if it's even visible on camera, there's an ever so slight yellow tint to some of the keys, but it's barely visible at all. So this turned out, I'm pretty pleased with this. In order to test this, I don't know if the membrane is damaged or anything like that, or some of the plungers. I am going to put the machine back together at this point and connect the keyboard and see if it works. So let's do that. This is going to be the first time you see the cleaned case parts, I think. So there's still some rust stains everywhere, things like that, but it is much cleaner than it was when I first got it. And here's what the bottom shield itself looks like. As you can see, there's still some rust on there. I'm just going to try to wipe it down again with some alcohol. I cleaned all the metal parts off camera a bit, and most of the rust just wiped away with some alcohol and some dish soap. But some of it you can still see some rust spots here, but I guess it doesn't get any better than this at this point. Remember, this was in a flooded basement, so it looks way better than before, at least. And the case turned out pretty pristine, at least from the outside. On the inside we still have some rust stains. I wasn't able to remove these, but it's the inside. Nobody's ever going to see this unless they take it apart. Yeah, so let me put the circuit board with the bottom shield in there. I think I might even leave the top shielding out of this machine completely. Might be a good idea to have some more room in there, and also ventilation is going to be a tiny bit better without the top shielding. It doesn't look bad at all. The case turned out really nicely, and the keys match the case now color-wise, mostly at least. Looks really shiny. Okay, is this still going to work? Power LED works, that's good. And now it takes the time, we discussed that earlier. It takes a long time to start up. Okay, there we go. It seems to work. I hope the keyboard still works. This seems to work absolutely. No worries. That is super amazing. Okay, reset. However, there's one last thing I want to add to this. That's why I didn't close the case completely. Let me open this up again. I want to add a little compact flash hard disk. So I made a video about this some years ago, actually, and I'm not going to go into this in any detail at this point. Just going to add this little clip. I am going to clean this thing off. This is the hard disk carriage, I don't know how to call this, where usually you would screw in a real live hard disk. However, this also doubles as a keyboard standoff, so we are going to put this back in here. Just slides into this, and we're going to put some insulation on here, and then we put the CF card on here, and I am going to install a workbench installation on here. So I'm just going to put some electrical tape on the hard disk carrier so we don't risk shorting anything out here. Yeah, this should just sit here. Maybe I'm going to tie it down with a cable tie. Just a little bit of extra security here, so we don't short this out with the keyboard assembly or something. Yeah, that should be fine. This is a 4 GB CF card, as you can see, and we are going to install Workbench 3.1 on this from disk. I'm not going to go into much detail about this process because you can just watch my older video about that and follow the steps there, and you should get to the point where we are going to get, hopefully. So yeah, let me install Workbench on this. I'm going to put the screws in at this point, I think, so we have a fully closed system. Yeah, and with the hard disk installed, or a CF card hard disk, this actually boots up much faster because it finds a hard disk when it looks for one and doesn't look forever. That's why it takes so long without a hard disk. I guess they assumed, kind of, when they made the Kickstart ROMs of that version, they assumed that everybody would have a hard disk at that point, but that was still pretty rare in the Amiga circles, especially for people who just wanted to play some games. They mostly had Commodore Amiga 1200s with just a disk drive and without a hard disk. So that took a long time to boot up. It's faster even if the hard disk isn't initialized or formatted or anything like that, just because the system finds a hard disk right away. So yeah, let's install Workbench on here. The 3.1 Workbench actually works fine with the 3.0 Kickstart ROMs. They made that backwards compatible, thankfully, so we shouldn't run into any issues here. And I'm just going through the whole installation process. I'm not going to bother you with the details. If you are interested in the details, just go watch my older video about that. Yeah, I managed to install Workbench 3.1 on here, and it seems to work absolutely no problems whatsoever. We can do all kinds of workbenchy things on this. This seems to be a fully working Amiga 1200 again, and it seems it is completely saved from the flood. Yeah, not only does it look nice, it also seems to pass all the diagnostic tests I threw at it. I'm using Keir Fraser's Amiga test kit here. I'll link that in the video description as well, so you can check that out. Pretty conclusive tests. Yep. Yeah, I think that's it for today. This restoration slash save turned out rather nicely, and this Amiga 1200 seems to fully work again. The case looks nice. There are some battle scars, but most of them happened probably before the flooding even happened. I retrobrighted the keys slightly. This now has a 4 GB CF hard disk in there that is going to be really useful. The disk drive works fine, the installation worked flawlessly, and everything else seems to just work on this. Fully recapped, basically as good as new. And I hope the owner is happy with this. I'm pretty pleased with how this turned out. I hope you were pleased with this video and enjoyed some bits of it. If you haven't watched the first part, I encourage you to do so, because you can see the state this machine arrived in the lab here was rather poorly. So yeah, thank you very much for watching. Thanks to everybody who supports me on Patreon or on the channel memberships page or elsewhere. Thanks for your subscriptions and your comments and the usual stuff. Hope to see you again on this channel. I'm Jan Beta. Thanks for watching. See you next time. Bye.